Find the domain of each of these functions. A, y equals x squared plus 2. For domain, there are only three things we have to worry about. We can't divide by 0. We can't have a negative under a radical. And if we have a log, we can't have a 0 or a negative inside. If you look at this first problem, there's no division, there's no radical, there's no log, so there are no restrictions anywhere on this. So the domain for this problem would be all real numbers. If we wanted to write this in interval notation, we would say this includes everything from negative infinity to infinity. B, y equals the square root of 3x minus 4. If we look at our three types of restrictions, we do have a radical on here. We need to make sure that the inside, 3x minus 4, is not negative. So we need to make sure this is greater than or equal to 0. Now we have an equation. Let's solve for x. We'll add 4 to both sides. So on the left-hand side, the 4's are gone, and we're left with 3x is greater than or equal to 4. Then to isolate for x, we divide both sides by 3. And we've got x is greater than or equal to 4/3. Now that we've isolated x, this is our domain. If you wanted to write this in interval notation, we would say our smallest value for x is 4/3, and we use square brackets because this was greater than or equal to. And this includes all numbers greater than 4/3 also, so from 4/3 to infinity. And in open parentheses, because infinity is not a number, it's never included in the domain. C, y equals x over x squared plus x minus 6. If you look at the three types of restrictions we have, division. We do have a division, so we need to make sure that the denominator is not 0. So we need x squared plus x minus 6 to not be equal to 0. Now this we can factor. So we can factor this as x plus 3 times x minus 2, and this is still not equal to 0. We can now split this into two separate inequalities. X plus 3 can't be 0, and x minus 2 also can't be 0. Now each of these will solve for x. For the first inequality, we subtract 3 on both sides, and this leaves us with x can't equal negative 3. If you look at the second inequality, we can add 2 on both sides. So on the left-hand side, the 2's cancel, and we're left with just x is not equal to 2. Now, to write this in interval notation, it might be helpful to draw a number line. So let's put negative 3 and positive 2 on a number line. And I know we can include everything to the left. Wrong button. We can include everything to the left of negative 3. So that means we're going to include everything from negative infinity to negative 3. We can also include everything from negative 3 up to positive 2, making sure not to include negative 3 itself. So we're also going to include everything from negative 3 to 2. And we're also going to include everything from 2 on upward, 2 to infinity. And because we have these three disjoint intervals, we're going to union each of these three together. So in interval notation, we would say our domain is negative infinity to negative 3, union negative 3 to 2, union 2 to infinity. Or if we were to write it in inequality notation, we would say that the domain is all x values other than negative 3 and